Slowest group I've ever had.
The slowest?
Slowest. Totally slowest. Okay.
Slowest?
Number 8. We are going to sketch this. Now, please keep in mind, yesterday at Open Gym, we discovered some students are relying way too heavily on the calculator. You will not have a calculator for all the problems 1 through 11. So if you use the calculator to do anything with those problems, make sure you can do them without, because you're not going to have a calculator. So even this one, you're going to do all by yourself. So we're going to plot our x-intercepts straight from the factors. And then we're going to notice that that one is squared. So I'm going to keep in mind and put a little X here to remind myself there's something special going to happen when I hit that 0. Now these are the x-intercepts. Now I'm going to find the y-intercept. And how do I find the y-intercept? Put 0 in. So I'm going to have 1/2 times 1 times 9 times 5, which is 45 halves. All right. Now, what's the degree of this polynomial?
2.
Well, it's even. It's 4, right? It's 4th degree. It's even. Which means it's going to start up, end up. That's a positive number. That doesn't change. So I'm going to start up here, pass through that point, pass through that one. I got to come up, pick up this point. When I hit to this one, though, it's going to bounce off and go back up, right? So that's it. That's all you have to worry about. Okay, Dan?
Yeah.
All right, who else? Reagan.
For 6A, I got the right answer, but I'm confused on how the 2, how it like cancels out when you do the quadratic equation. So I got 2 radical 23 instead of -4, or 8. Never mind, you can just work out the polynomials.
Okay, now, but when I look at that problem, the first thing I notice is it groups. So I'm going to group it.
Wait, 6A?
Yeah.
6A over equation 2. It factors by grouping. So I want to do it that way first, because that's the most efficient way to do it, but then I'll do whatever you did there, and we'll see if we can figure out what you're doing. So x plus 3 is my common factor, x squared minus 4. So x plus 3, x plus 2, x minus 2. So the roots should be -3, -2, and 2. That should be the answers to the question. Okay, now what did you do?
I'm sorry, I was talking about 6B.
Okay.
I'm so sorry.
Okay, 6b is a quadratic that doesn't factor, so I am going to use the quadratic formula on it. So -b plus or minus the square root of b squared minus 4ac all over 2a. Is that okay with you? So that's -8 plus or minus the square root of 64 plus 28, is that 92? So then I just have to worry about, does 92 break down? Well, it's 2 times 46, which is, so it breaks down into 2 root 23. Here, a 2 here, and a 2 here, so I'll cancel all those out, and I get -4 plus or minus the square root of 23.
Okay, thank you.
Okay, who else on the review sheet has a question for us to tackle? Teresa. 13. All right, let's look at 13. Okay, how did you start, Teresa?
I set the 2 equations.
All right, and that makes perfectly good sense because the problem says supply will equal demand. So we'll set them equal to each other. Okay, then what did you do? So I got everything over on one side. Okay, so we've got 0.02 p cubed plus 0.001 p squared minus 5. Okay, then what? It does not factor. I'm not saying you couldn't potentially find factors. Probably not. You can do PRRs and all that stuff, but this is on the calculator part of the test. So the quickest way to do it, if you're at this point, then the quickest way to do it is go ahead and graph this equation. And what will I be looking for? I'm going to go ahead and graph this. No, I'm not looking for the maximum. I'm looking for the zeros. I'm looking for the zeros. I want to know, where does this equation equal 0? So I'll second calc 0. And I got on my calculator about 6.28. Now what is that? That is the price where supply equals demand, so $6.28. There we go. Now, this is a great way to do the problem, but it's not the only way, remember? What's the other thing you could do if you're more comfortable, Lily?
If you plug 2 equations into your calculator and then find
Where they intersect, yeah. So instead of doing second calc 0, do second calc intersect. Have these graphed as separate equations, right? And go from there. Okay, yeah.
Number 15.
15. Okay, what did you set up as an equation here? Obviously, we're supposed to be talking about area.
Oh, I'm sorry. Actually, number 14.
Okay. Got an issue with problem numbers this morning. Okay, 14. All right, so what's your setup for that one?
I did 60 plus 10x, parentheses 2 minus 0.25x.
All right, let's double check that and make sure he's right. If X is the number of days I wait, then 60 plus 10x, does that make sense to everybody? And 2 minus 0.25x makes sense to everybody? All right, so what do I do with that equation? What am I looking for? This one I was looking for where it equaled 0. Is that what I'm doing here? I want the maximum. Kids, you do not want the revenue to be 0, do you? What would that mean if your revenue were 0? You are not making any money, right? That is not a good situation. You want the maximum. So how do I go about finding the maximum? Foil it out. Hopefully foiled correctly. And then what?
On the maximum.
X equals negative b over 2a. It looks like 1. So answer the question then. How many days should she wait? 1 day.
If we were to ask, like, what's the maximum revenue, how would you find that?
How do you think you would find that?
Would you plug the 1 into everything?
Absolutely, that's your revenue
Okay.
equation. All right, who else? Katie? 10. So we got an equation that gives the height of the ball. This is the height right here, that's the height. When does it reach its maximum?
On the vertex.
This is a squared equation. The word maximum is being used. What does that automatically mean?
Vertex.
We want the vertex. So the vertex will be negative b over 2a, which reduces to 5/2. Now, I said x. What letter should I have used?
S, T.
T, right? That's the x in this problem, it's t. So the question is, when does it reach its maximum height? When does it reach its maximum height? 5/2 seconds, 2.5 seconds. How high does it go? How do I find the height? I plug 5/2 in for t. I find s of 5/2. So that is what, 100 minus 25, 4 is 50 feet? Double check my arithmetic. Okay? When does the ball hit the ground? Go back to your original equation. What do you know if the ball's on the ground?
0.
Its height is 0. So we'll solve the equation. That one factors. So I'm going to get 2 different answers. What are the 2 different answers I'm going to get here? 0 and 5. So one's the ball on the ground at the beginning, and then after 5 seconds.
Wouldn't you have been able to get the answer by multiplying this number of seconds times 2?
If you gotta be careful. That symmetry thing works great as long as the ball starts on the ground. As long as you can recognize that this is the ball starting on the ground, you're good. But if the ball started off the top of a building or something, that would not work. So I just want to caution you about that. All right, who else? Robert?
For number 11 is directly, like, v k equals vp.
Well, it's y equals kx, that's what we memorized, but in our problem it would be, oh wait, that's directly, we're doing inversely. So what's inversely? Y equals k over x. So volume varies inversely with pressure, so that would be your setup for that problem.
Okay.
Dan?
Can you actually do 15?
All right, this is area, so what's your equation going to look like? Area is going to be length times width. And we want our area to be 10384. What's the length of this whole thing? House and yard.
60 plus x.
60 plus x. What's the width of the whole thing, house and yard? 30 plus x. What kind of an equation is that?
Quadratic.
That's quadratic. Does the problem say anything about maximizing? Am I looking for a maximum? No, I'm looking to solve this equation. I'm looking to figure out what x's are gonna give me 10,384, right? So what am I gonna do? Foil it out, but it said equal to 0. Okay, here we go. 1,500 plus. Okay, so I've got x squared plus 90x, what's that? Minus 8,584. Now chances are, especially if I got this problem out of a book somewhere, chances are that factors, but I have no idea. So I'm not gonna waste time. I have my calculator, so I'm just gonna use the quadratic formula. And the numbers are big, but it doesn't matter to me because notice that one of the answers is gonna be negative, right? Not interested in that one. I got 58. Is that right? That seems awful
Yeah.
good. Anybody else match that? Okay. So let's answer the question then. That's my x value. Find x, the distance between the house and the fence. So that would be 58 feet. Okay? All right, let me throw a few more at you here and see how you do. All right, let's start with this. Descartes' rule of signs. I haven't practiced that in a while. Remember, Descartes' rule of signs gives us the number of positive real roots, the number of negative real roots, and the number of imaginary roots, right? So here we go. Positive real roots. Stuff's missing, it doesn't matter. It only matters when you're dividing. It doesn't matter any other time. So I'm just going to count sign changes. Here we go, right? 1, 2, 3 sign changes?
So it'd be 3 or 1.
So it would be 3 or 1.
Why would it be 1?
Somebody tell her.
It goes down by 2.
Always goes down by 2s. That's part of the rule, right? That's the confusing part of the rule, the part that makes it hideous. But it is part of the rule. Now, how do I do negative reals? Same way, except
Make the x negative.
I pretend x is a negative number. So if x were negative, this term would be negative, wouldn't it?
Yeah.
This term would be negative. This term would be negative, and this term would be negative. Whoa, whoa, whoa. How many negative real roots are there?
2.
None. Did I see any sign changes? Now that's helpful, right? Because if I were actually solving this problem, looking for the zeros, what would I know not to try? No negatives are going to work. Don't even waste your time. Well, if 3 are positive and none are negative, how many does that leave to be imaginary?
8.
8.
Or 10.
If 1 is positive and none are negative, then that would leave 10. And what did I tell you about this bottom row of numbers? They have to be even. If you do your stuff and this turns out to be a 7, you know you have a mistake, because what's true of the complex roots?
Yeah, come in
They
pairs.
always come in pairs. So that bottom row has got to be evens.
So if, for positive real, if the sign changed 4 times, would it be 4, 2?
Or 0.
4, 0?
4, 2, or 0.
Okay.
Count down by 2s.
Yeah.
Here 2. If there had been 6 sign changes, it would be 6 or 4 or 2 or 9.
Yeah,
10 and 1, and then 0.
yeah, I think so. I wasn't sure until you wrote that out, but I think so.
Okay? Find the remainder. Find the remainder. What are you gonna do? Will?
Plug -1.
Plug -1 in. You pretend like this is a function and just plug in -1. So if you put in -1, this is going to be -3. This is going to be -14. +7, +1, -8. So we'll just total all that up. -17, double check that. Yeah. Okay, so nobody is going to write me a little note on the test that says there's not enough room to work this problem. Right? We're not gonna do that anymore.
For that one, you could just leave as -17, you have to put it over x
Right.
plus 1.
All right, how about this one? This is the meat and potatoes of the chapter so far, anyway. Find the zeros. Find the zeros. It does not group, right? And it isn't quadratic. If it's quadratic, you can use the quadratic formula. If it groups, you can group it. This one does not group. So, what do you think?
To find your possible rational roots.
And there'll probably be a problem where you actually have to list them, so we'll practice one of those in a minute. But I'm just thinking about them in my head, and I just quickly was running through. I can see 1 isn't going to work, because when I put 1 in, this 30 is way too big. I'm not going to get 0, right? Remember, I'm trying to get 0. But it looks like 3 might work, so I'm going to try 3. It does. Now, of course, you're going to be guessing your own numbers. What do you do after you have found one that works? Whatever number it is that you find that works, what do you do then? Divide it out, and then what?
Right there.
So this is x squared minus 3x minus 10. Either factor that or use the quadratic formula. I think that factors so what are the roots? The question was find the roots of this polynomial. What are you going to put the answer behind x equals? 3, 5, or -2. Don't forget the one that you originally guessed. Bailey?
Oh, could we go with the one where there's none of the PRRs?
And then what? If none of the PRRs work, that would have to be a calculator problem. Let's try this. Let's list the PRRs for 3x cubed minus 8x plus 7. gotta make a list, plus or minus. What's in the list? 7, 1, 7/3, and 1/3. Everybody good with that? All right, Anna loves flowers. She has done some research, and she discovered that for every $2 increase in price, she will lose 5 customers. So if the price goes up $2 on her bouquets, she's going to lose 5 customers. The current price is $12 and 100 customers. Find the number of bouquets that she can expect to sell to maximize her income. So the question is, how many bouquets can she sell, or will she sell to maximize her income? All right, I know you don't have a problem in front of you. The important stuff is every $2 increase leads to 5 fewer customers. We're starting at $12 and 100 customers. We want to maximize our income. We have done a zillion of these problems. How do we maximize our income? What's that equation going to look like? Our revenue or our income equals what? 12 plus 2x. $12 plus a $2 increase increments. X will be the number of increases times what? 100 minus 5x. The customers are going down in groups of 5. The money is going up in groups of 2. So we've got negative 10x squared plus 140x plus 1200 if I multiply it right. So what do I do? That's my equation. That's my revenue equation, my income equation. What do I do now? Find the vertex. Why do I want to find the vertex? Because the question said I want to maximize. What does that 7 represent? The number of increases. The question was, how many bouquets is she going to sell? Okay, now wait a minute. How many bouquets did she sell to start with? 100. What happens to that 100? Every time you have an increase, you lose 5 customers, right? How many increases are we going to have? So how many customers are we going to lose? So how many are we going to have left? 65 customers. Tom throws a javelin from the top of a building so that its height above the ground is given by this equation. Okay, so a guy standing on top of a building throwing a javelin. Question is, when does it hit the ground? What are you going to do? Set it equal to 0. Why do we set it equal to 0? Because it's on the ground, and this gives us the height. If it's on the ground, the height has to be 0. So what do we do with that equation? We solve it, right? It's a quadratic equation, so I'm going to solve it. If you want to, this is completely optional, if you want to, it's set equal to 0, so the whole thing could be divided by -8. If you wanted to. That just brings, oh, I could do more than that, I could do 16. -16. The whole thing's divisible, that's nice. And now, that's all that's left, I can factor that. So when does the ball, or the javelin hit the ground? After 5 seconds, yeah. You could also have used the quadratic formula. Whatever occurs to you when you see it. Will?
Do you not need to worry about the -16 to take out?
Not when it's set equal to 0. If it's set equal to y, if you're maximizing and it's set equal to y, then yeah, you can't do that. But if it's set equal to, that's a regular equation, you can divide. Okay, now how about this one? I have a polynomial whose roots are 2 and 4i. Write the equation of the polynomial. Okay, what do we do? Ready.
Since there's a 4i, there has to be a -4i.
Perfect.
So it'd be x minus 2 times x plus 4i, x minus 4i.
And this root actually goes with this factor, and this one goes with this factor. The order doesn't matter. And then what?
And you factor the 4i's, and then after that you factor with the x minus 2.
So it's going to be x squared minus 4ix plus 4ix minus 16i squared. Minus 16i squared is plus 16. And then you're right, we still have the x minus 2 that we had before. So that's x cubed minus 2x squared plus 16x minus 32. There's your equation. Anybody have a question about that? All right, now I'm gonna make this one up. Who knows what the answer is? So we're gonna do it, but not worry about the answer because I'm totally making it up. Well, let's suppose we have a supply function that is -0.001 p cubed minus 8p plus 4. We are going to make widgets. This is the supply of widgets at a given price. The demand for the widgets, that is the number I can sell at the given price, is this. How about a number? Find the price where supply equals demand, right? You do this on your own, because there's 2 different ways to do it. I don't want to lead you, you do it the way you want. But find the price where supply equals demand. actually got two answers. Did you? Anybody else get those two answers? Anybody get either one of those two answers? So let's review. Everybody should have an answer by now. You're doing this on your calculator, so you should not be floundering out there. What's your strategy? Okay, one strategy is set them equal to each other. So the equation that you're solving is 0.01 p to the 4th plus 0.001 p cubed minus 2p squared plus 8p plus 2. Added that, subtracted that, yeah. So if you do it this way, you're going to put that into your calculator and you're going to check and see where it crosses the x-axis. And I had it crossing twice on my picture. Now what's the, and then so what button do I use once I get this picture? Second calc, and look for zeros. Now, who did it a different way? Lily, you talked about this before. What did you do?
I plugged those.
Put this in as one equation, y1. Put this in as y2, and then press what button? Second calc, intersect.
I got a different answer.
Did somebody say you matched this?
I counted that as equation. But I didn't get those zeros.
You did get those zeros? I could have the wrong zeros then. No, I don't think so.
Ford,
Yeah.
can you please send Trevor Ford to the front office at the bell?
Uh-huh.
Thank you.
Did you hear that, Trevor?
Yeah, I heard that.
Okay, let's all try this again real quick. I'll do it the other way this time.
Mrs. Ford,
Uh-huh.
when you solve for the equation, like set it equal to 0, is that when you look for the zeros?
Is that equal to 0? 0.
Did your dad not care what you're facing this? Did he care? Really?
All right, well, you got your homework.
No, you like to make school. Oh, yeah.
Okay, there are definitely 2 points of intersection.
No, you can
Have a good day.
Mrs. Ford, the junior still doesn't have to.
Yeah, that's how it works. Oh, that's gonna be so hard.
Wait,
Yeah.
you don't like
It's gonna be like,
There's 4.
That'd be fun.
Just like a dice.
Let's bring breakfast.
All right, have a good day.
Oh, now I'm sad. I'm really jealous. Bring like donuts or something. That'd be awesome.
Bye, honey.